Alright, so today we are going to be talking about lesson 10.4, which is going to be independent versus dependent events. So telling whether two events are independent or dependent is really essential for determining how we calculate their probabilities. So I'm going to show you the tools you need to be able to identify these two things. You're going to notice a new type of notation they use, probability of B/A. What that means is that's the probability that something will happen given something else has already occurred. So that's what that means. You see that little note there that explains it. So you can always reference that back if you ever forget what that means. So these rules do extend out to multiple events. So the easiest way for me to show you is to just do an example with it so you can get a gauge of how these two things differentiate. Okay? Let me turn my volume off because the emails are going to be flying in. All right. Zoom in. So we're going to determine if these events are dependent or independent, and then we're going to calculate their respective probabilities. So selecting a king from a deck of 52 cards after replacing the king in the deck, selecting a queen from a deck of cards. So the first thing I want you to look at is the phrasing. After replacing is the important phrase in this situation. So if I took a card from a deck, okay, and then I put it back, is anyone really going to know that the deck has changed?
No.
Likely.
No. So that is what we call independent events, because we reset the deck. We call it resetting the probability. Okay, you put the deck back to its normal state, and then you choose a new probability. Okay? So what is the chance of selecting a king from a deck of 52 cards?
4.
Good. And then we use the word and, which means we use addition or multiplication?
Addition.
Multiplication.
Multiplication. What do we use addition for?
Or.
And then we want to select a queen. What's the chance of selecting a queen?
4 out of 52.
Good. So with multiplication, we multiply straight across. That gives me 16 out of 2,704. So that's approximately 0.59%. So pretty slim chance.
Where is this?
Oh, it's on the very back of that page, like the very, if you flip it over. There.
1545.
Oh, I gave you today's instead of yesterday's.
Okay.
So yeah, you're gonna need that for the homework, but here's the notes that we're doing.
Okay.
All right. Pause for a second for you to catch that. Okay, so selecting a king from a deck of cards, 52 cards without replacing the king. So what do you notice is different about this question as opposed to the previous one? Without replacement. So this is not independent, it's good, because the second probability will depend on how the first one goes. So what is the chance of selecting a king from a deck of cards?
4 out of 52.
Good. And times, now here's where we have to be careful. Selecting a queen from a deck of cards. How many cards are there now in the deck?
51.
Out of, how many queens are still in the deck?
4.
4. Because we didn't pick a queen. If we had picked a queen, that would have affected the queen's probability. That gives me 16 over 2,652. Which is approximately 0.6%. So while these probabilities are almost the same, why is B marginally larger than the previous?
Because you're still picking cards. Yeah.
Yeah, so if you don't replace, you have 51 cards to choose from instead of 52, so your chances are a little bit better. Just marginally better, but a little bit. That's why the probability changes just slightly. Alright, so now we're going to be doing a jar of marbles problems. You've seen these probably in middle school, right? You remember doing these problems in middle school where they give you the different marbles and you have to calculate the probabilities? So we're going to do that but add another, more advanced layer to it. So if we have 7 red marbles, 3 blue marbles, and 10 green marbles, how many total marbles do we have?
20.
So we have 20 marbles. Okay. So what is the probability a blue marble is selected after selecting and replacing a red marble? So after selecting and replacing, is this independent or dependent?
Independent.
Good. A red marble. So the first thing we're doing is we're picking a red marble. So everybody see why that event occurs first. What is the chance of picking a red marble?
7 out of 20.
Good. Times, what is the chance of then picking a blue marble?
3 out of 20.
Good. And why doesn't that second denominator change? Bless you.
Because you replaced.
Because we replaced it. That's going to give you 5.25%. Anyone have any questions about that? No? Okay. What is the probability that a blue marble is selected after selecting and keeping a red marble?
What was the percentage of the last one?
5.25. So you're selecting and keeping the red marble. So is that independent or dependent? Dependent. So the first thing you're doing is you're picking a red marble. What is the chance of picking a red marble?
7 out.
Times, what is now the chance of picking a blue marble?
3 out of 19.
3 out of 19, because we took a marble and didn't replace it, so now the stack or the bag only has 19. Yes. And then we do the division.
You're either needing both.
Yep.
5.5.
I'm getting 5.5%. So as you can see, by not replacing, the probability has went up about 0.25%. Does everybody understand why it's went up? Just a little bit. Okay. Now we're going to do a problem involving students. So we have 1 freshman, 2 sophomores, 4 juniors, and 5 seniors. And they're going to be randomly chosen to read their essays at a town fair.
Oh, yikes. That would suck.
So what is the total number of students in this pool of students to choose from?
11. 12. Oh, 12.
12. I know you guys don't like when they're written as words. You've probably been noticing that a lot in the homework, and so there's 12 total students. So we have to be careful on this one because this requires you to imply something. What is the probability that a junior, so what's the firstly, what is the probability that a junior is selected?
4 out of 12.
Good. Times, because it's a senior. So here's the thing. The question doesn't explicitly say that you have not replaced, right? Or replaced.
But it says it's people.
Exactly. So this is one of those scenarios, thank you, where you have to imply that it's without replacement. Because you're not going to pick the same student to read the same essay twice, right? So how many students now are left in the pool to choose from?
11.
And we're trying to choose a senior. How many of them do we have?
5.
Good. So that's going to be 20 over 132, which is approximately 15%. So you have a 15% chance of choosing those people correctly. So if you were to just randomly pick a junior and then a senior, you would have a 15% chance of accuracy. Any questions about that? So now we have the same scenario, same total number of students, but now we're going to try to pick 3 people. Okay, we're going to see if we can pick all 3 correctly instead of just the 2. Is it going to be easier to pick 2 correctly or 3 correctly?
2 correctly.
Good. So if I said to you you have to pick 2 numbers I'm thinking of, that's easier than picking all 3 numbers, right? So, firstly, the probability of a junior is?
4 out of 12.
Good. The probability of senior number 1 is?
5 out of 11.
Good. Now we have to be careful. Senior number 2?
5 out of 10.
4 to 10.
4 out of 10.
Oh wait, senior? Oh.
Do you see?
Yes.
Oh, wait, never mind.
So, this goes down every time because the pool goes down every time.
Right, but so then what about the numerator then?
The numerator here is because this was specifically only dealing with juniors for this one. We only picked 1 set of juniors. Then we picked from the 5 seniors. But when we do the next one, there's only 4 seniors left to choose
I
from.
thought the first 4 was for seniors, then it was juniors, then it was senior.
Oh, I gotcha.
Oh,
Yeah, I just want to make sure everybody was clear on it, so hopefully that makes sense now. But yeah, because we picked from the same pool of students we already picked from, that's why we deplete the numerator as well. So we do the math.
that's a big number for the denominator.
Yes, it is. So you have a 6% chance.
I got 7.57.
I think you might have divided by 1, 2, 3, 0. My guess.
Right, 1320. For some reason our numerators are different.
Oh, that's
You
6%
look on
even.
5 and it becomes
It's 6.1 technically.
Okay.
Yeah, 6.1.
All right. So, does anyone have any questions? And do you all understand why the chance has decreased when you have to pick all 3?
Yes.
That's like if you're playing like a Powerball and you have to pick 3 numbers instead of 2. Much harder. So odds get better.
Why are the denominators different?
Because each time that you pick a student, they're removed from the pool of students to pick from. So like if I had 12 students, I picked 1 from that group. So now that student's not in the group anymore. So each time it's going to go down. Now there's a few words to know when the denominator is going to change. Either the word then, which I put some tips on the board, when they use the word then, and when you can tell that it's a dependent. Those are the 2 situations where you want to deplete your denominator. Okay? Make sense?
So basically you just have to figure out like what's the then problem without saying then.